Hello everyone, and welcome back to another video. Today I'm just gonna do LeetCode problems on linked lists, and gotta do my dailies, even though I haven't done it for like a month or two now, unfortunately, but it's whatever. Okay, so what I have here is, it's an easy question, it's on linked list, and as this, it says right here, merge two sorted list. So we are given two lists, list 1 and list 2, and they're both sorted already, so it makes it a lot. So it's an easy question because the lists are already sorted. You don't have to sort them out and then merge. All we got to do is just merge them. I'm gonna write the code out first, and then afterward I will explain what each line does. Okay, so let's see. First, I'm gonna create a dummy node. Is basically to simplify the process. So list node dummy equals new list node 0. And then we have another list node, and it's called current, and it's gonna equal to dummy. This is basically like a pointer. So we have a current pointer and it's pointing at dummy. Now we're gonna create a while loop that's gonna iterate through both lists. First, create a while statement. So we're gonna have it where list 1 is not equal to null and list 2 not equal to null. And we're doing that because of example 3. So while it's true, we're gonna write an if statement. If list.1 value is less than or equal to list2.value, then we're gonna put current.next, which is the current pointer that's pointing the dummy. The current next is gonna be pointing at list 1, which is the first value of the list in list 1. And then afterward, we're gonna put list 1 equals list1.next. Let's have the else statement, and that else statement is gonna basically be the other way around. If list 2's value is less than list 1. And when that's the case, you kind of write the same thing, except this time the current.next will be pointing at 2, and then list 2 will be list2.next. Oops. There we go. And then after the if else statement is complete, we're gonna write the move current pointer. So let me write a comment down first. Move current pointer to the last added node. So it'll just be current equals current.next. As to basically moving forward, Now we're gonna write, now that the while statement is complete, we're gonna write cases for example 3. The while statement is actually for example 2 and 1 and 2 basically. Just for 1. I'll explain it after writing it, whatever. We're gonna have if list 1 is not equal to null, then the current.next equals list 1. If list 2 is not equal to null, then the current.next equals to list 2. Okay, and I'm gonna write a comment for these. If there are remaining nodes in list 1, append them. Same goes here. If there are remaining nodes in list 2, append them. Perfect. After that, we're gonna go up here, and then we're gonna write return dummy.next. For this part, it's gonna basically return the merge list, but it's gonna start from the next of the dummy node. Okay, let's see, run it. It should result in all 3 cases. Yep. Yep, they're all accepted. Perfect. Okay, now I'm gonna explain what basically each line does. Okay, what we have on the first two, it was part of the template already or whatever. So it's the definition of merge to list functions, and it's gonna take in two parameters, which is list one and list two. So yeah, and that's it. And then the goal is to merge the two sorted lists into a new sorted list. So what I have here is we have the dummy node, and it's gonna have a value of 0. The dummy node would just serve as the starting point of the merge list. Okay? What we have here is the current. This current is basically a pointer and is initialized to point at the dummy node. And this pointer is gonna be used to basically build the list by adding nodes from either list 1 or 2. This is the while loop. At the start of the while loop, it's gonna continue as long as both list 1 and list 2 are not null. With the whole point of this part is we're comparing both lists and add the smaller number of the two to merge the list, basically. And then the condition is basically the loop's gonna run as long as both lists still have remaining nodes together. So if either list is exhausted, or let's say if on example 3, if list 1 has nothing but list 2 has a 0 or value, then this while loop would never begin. Or if list 1 has like 4 values but list 2 only has 2, then it's gonna do the while loop on the first 2 for each list, and then it's gonna stop because this part is no longer true. The condition is no longer true. Anyway, so what we have here is the if and else statement. So yeah, if value 1 is less than or equal to list 2 value, if that's the case, then the first number should be from list 1. And that's why we have the current.next pointing out list 1. And then we have, obviously afterward, we have to move the list 1 to the next value. So we have list 1 equals list.next. And if that wasn't the case, then list 2 would be the one to be in it. Now, it's kind of weird on the example 1, because what is supposed to happen is it's supposed to be the red 1 instead of the purple 1, because this should be list 1 and this is list 2, just like how it's written in the input. So I think it's just probably a visual, is like an error or something. This should be red color and this should be purple. Whatever, anyway. So yeah, basically in both cases, after attaching a node to the, basically for these two, after attaching a node to the merge list, we move the current pointer to the current.next. This way, which is the node we just added to the list, So we're just making sure we're building the merge list correctly. And then after attaching a node from either list 1 or list 2, we move the current pointer to current.next. This way, so we can continue and add like any new nodes, Now what we have here is, okay, so that's just the end of the while loop. What we have here for both of these is once you exit the while loop, one of the lists might still have remaining nodes. So both of these are gonna check if either one still has nodes left, And since like list 1's already sorted, we don't really need to compare the nodes. We can just add the remaining. And then finally, you basically just return the dummy.next. The dummy node is just a placeholder. And the merge list actually starts from dummy.next. And yeah, that should be it. And yeah, since the case works, but just in case, let's look at the example for example 1, 2, and 3. So what we have here is example 1, list 1 and list 2. So both list 1 and list 2 are not pointing at null, meaning they have a value inside. And what's gonna happen is it's gonna compare the first of list 1 and list 2, right? So since list 1 first value is equal to list 2's first value, the first if statement is correct. If that's the case, then current.next will be pointing here. So pretend there's a dummy node right here, and that dummy node is gonna point at the red 1. Now we moved the list to list.next. So it's gonna be looking at 2 now. Now what's happening is we're comparing the number 2 and the number 1 down here. And since the list.2 value is less than list.1, we're over here on the else statement, making the next pointer, the next current pointer, pointing at the purple one. So it's gonna have like a pointer down here, and then list2 equals list2.next. It's gonna repeat this process. So what's gonna happen is since 2 is less than 3, pointer at 2, move to 4, and since 3 is less than 4, the pointer is gonna point at 3, and then it's gonna move to 4, and repeat the process over, So this part makes sense. This part, I think it's just a bug or error, whatever you want to call it. Example 2, it has nothing, meaning this is false. Is there anything here? This is also false. So all you're returning is just nothing, basically. Right? Yep, and that's it. Now example 3 is the interesting one because this part will be false because list 1 is equal to null, but list 2 is not. So we're not doing the while, but we are doing one of these because it says that if list 2 is not equal to null, which is true, then the current.next would be pointing at list 2, which means that the dummy node has a pointer, that current pointer is pointing at 0, and then we just return dummy.next, which is returning 0, and that's it. So case 3, see, the output is, just 0. And that's basically it. Yeah. Thanks for watching. Okay, after finishing recording, I forgot to mention the time complexity and space complexity. So I'm just gonna do that real quick. Okay. Time complexity, big O of n plus n. That's it. Now, n is the length of list 1, n is the length of list 2. List 1 and list 2, they can be 2 different lengths, 2 different amount of values inside, nodes inside, like example 3 for, so it cannot be like example 1 where they're the same amount or the same length. If that's really the case the whole time for every example, then yes, there's no point of putting an n, it will also be an n. But since that's not the case, it will be big O of n plus n. And space complexity would just be big O of 1. The reason for that is we're just manipulating the pointers to merge the list. So just manipulating the pointers to merge the list. And that's it. It's just a little bit of extra space, nothing else. And yeah, that should be it. All right, thanks for watching now.